So we'll start from we'll start in a couple of minutes. But if you have any questions on the previous session, on how things are going, or anything else, please feel free to ask me right now. We can spend 2, 3 minutes, 4 minutes on that. A lot of students have joined us for our new DI course. So if you are one of them, you can ask about that as well, in case you have any doubts about that, or in general, any question you have regarding your preparation and so on. Also, let me know if you can hear my voice, because at least if one person can comment, I would know that you can hear my voice. Okay, thanks, Anshuman. Thanks, Ashra. Okay. So let's just wait for 1 or 2 more minutes and then we'll get started. What is in general the idea around geometry? Is it easy, difficult? People find it tough. People find it easier than the other topics in quant. Personally, I was generally a bit more comfortable in geometry, but still I was always much more comfortable in algebra and so on. In geometry, I knew I would do the question, but I always felt that others would also do the question. In algebra, etc., I felt I had a slight advantage that others won't be able to do, but I would be able to do it. So Rohit is saying there are too many rules. Ashraf says he finds it tough. Rohit, there are too many rules, but if you look at the questions and what is asked, it's generally not asked from too many rules. It's asked from few specific stuff. So there is a lot of stuff out there, but if you focus just on the concrete part, then what the important parts, then also you should be able to do most of the questions. So you need not be worried a lot about too many rules. Uh, Vishudip says, find it difficult to link concepts in geometry. Should not be the case. If you know the things that you know properly, then most of the question you should be able to solve. There will be a few which you would not be, but in general, you should be able to solve. So let's look at it. What we'll do is, I won't go a lot into the basics, but I would mention the basics so that you know what you need to look at in case you haven't looked at it. And then we'll solve some questions. The idea again here is to, one, give you exposure to different kinds of questions and different concepts, and to also remove some of the fear that you guys are mentioning, that you think there are too many rules or there is too much to look at, and so you get confused and you don't know which theorem or which rule will be applied and so on. So the way the classes would be held is, I'm hoping to cover triangles in 2 sessions. So today we'll do some questions and then we'll do some more questions in the next session, and then later on we'll have one more session on difficult questions, etc. But that's the idea. So let's get started, because the less time we waste here, the more we'll be able to cover. So most of you know these properties. Just for the sake of covering, sum of all angles of a triangle equal to 180 degree. Always remember this. You think it's fairly obvious, but a lot of you will miss questions where you just had to apply this at some point. Sum of two sides of a triangle is always greater than the third side, and difference of two sides of a triangle is always less than the third side. Remember this also. Many a times you get inequalities and so on for questions based on what can be the possible length of the side, and so there these kind of properties help. These two people do generally miss, and questions are asked, so you should actually know. Sine rule is a by sine a equal to b by sine b. And I have mentioned them because I used to take them a bit lightly, as in I would never be sure of what exactly was the formula and so on. And that's not a good thing, because these are applied generally. So you should remember this one, where A, B, and C are sides of a triangle. So if a triangle is A, B, and C, and the opposite side is of length A, B, and C, then this length A divided by sine of this angle will be equal to B by sine B, will be equal to C by sine C. So that you should remember. This formula is a important one, and the cosine rule is also something which you should remember. I'll try and draw a right angle-ish triangle. My drawing is very bad, so so here what you have is, if you have A, B, and C, and the sides opposite have lengths A, B, and C, then the formula is C square is equal to A square plus B square minus 2AB cos C. Now you need to remember this. What is the sign here? What is whether it's cos or sine? Please remember it. This one gets used reasonably a lot. So you will run into situations where you know two sides and the angle which is enclosing them. So here you'd see A, B, and cos C is the angle between A and B. So if for this triangle I know this length and the angle in between, I can calculate the third side. So it's an important formula. If C becomes equal to 90 degree, then cos 90, if you remember, is equal to 0. We'll do a bit of trigonometry in the next class, but cos 90 is equal to 0, in which case this formula turns to C square equal to A square plus B square, which is your Pythagorean theorem. So try and remember these two, might be helpful. Very quickly, we'll cover a few basic things before going ahead. What is an isosceles triangle? Isosceles triangle are triangle whose two sides are equal. If two sides are equal, these angles are also equal. We'll look at the properties in detail in the next class for all these three. We'll do some questions, but we'll look at a property in detail. But at least remember this. The two sides are equal, the angles are equal. Even if you remember this much, you will be able to solve most of the questions. You don't need to remember all the funky properties and everything else for most questions. In some cases, you might need. Equilateral triangle, one step ahead, you'll have all three sides equal. Three sides equal and all three angles will also be equal. So all three angles will be equal to 60 degree. This you should remember. In this case, I will cover it in the next class, but I'm just touching on it today itself. The line which divides the other side into two, which is the median, will be the same as the perpendicular to the other side, will be the same as the perpendicular bisector of the other side. So all those four lines coincide for equilateral triangle. Remember that. This line you can calculate also. If the equilateral triangle side, one side is A, then since it divides the other side into two, this will be A by 2. And using this, you can calculate this height of this, which will be using Pythagorean theorem, A square minus A square by 4, which will be, if you do it, root 3A by 2. So the height of the equilateral triangle is root 3A by 2, where A is the side of the triangle. And then you can also calculate the area of the triangle using that, just in terms of A. So half into base into hypotenuse, so half into A into root 3A by 2. And that becomes root 3 by 4A square. So this is a good thing to remember. Sometimes you just get the side of a triangle, of an equilateral triangle. You might be asked about the area. So you can just remember it using this formula, root 3 by 4A square. So this is an equilateral triangle. Right angle triangle, again, most of you know very quickly. Right angle triangle is just a triangle whose one of the sides is 90 degree. The only thing you need to, there are a lot of things you need to remember, but one thing which you should remember is that they follow the Pythagorean formula, which is A square plus B square is equal to C square. So just touching on this, let's look at a few questions that will warm you up, plus also ensure that we are not going into theory a lot and leaving out questions. So here we have a figure which is given below. So AD and AE are given as 4 centimeters. So this is an isosceles triangle. And this side is 4 and this side is 4. BD and CE is 2. So these are also equal. This is 2 and this is 2. And BC is a straight line. So this is a straight line. And angle ADE is 60. So angle ADE is 60. If this is a straight line, this will be 120. So which means this angle is 120 degree. Okay. So we have been asked to find the length of AB. Now, if you remember cosine rule, it's very simple. Where you know two sides and you know the angle in between, so you can calculate the other side. That's why I said this rule is a one which gets applied fairly a lot. So 4 square plus 2 square. So we had A square plus B square minus 2AB minus 2 into 4 into 2 into cos 120. Okay. Now, you should not be thinking about the formula in the exam, and I keep repeating it again and again because it is important. These formulas should be on your fingertips. You should know them like the back of your hand. You should not be thinking about what cos 120 is. You should know that this is minus 1 by 2. There should not be any confusion in your head, because that will ensure that you solve these questions quickly. And then this is minus 1 by 2, so 2 gets cancelled, so this comes 8, and then you get to 32, which means AB will be equal to root of 32 or 4 root 2. So this is how you can solve the question. Okay, so you get the length of AB as 4 root 2, and you can calculate others also wherever is needed. This is also 4 root 2. You might be asked to calculate this length, and we'll see. However, you can calculate this length also. Again, the same cosine rule. This is 60. Actually, this is a equilateral triangle, because if this is 60, then all three will be 60. So this length will be 4 centimeter. So you can calculate all the lengths. You can calculate area or whatever is asked. There's this theorem which is slightly ignored, but I think it's important. I'm not covering all the theorems, but I'm covering the one which I think people will ignore and which are important. So I'm just trying to focus on that. The theorem states that if this angle is if AD is a bisector of the opposite angle, then the ratio in which it divides the opposite end is the same as the ratio of AB is to AC. So basically it's saying that if I take the bisector of this angle and join it to the other end, then this side which is AB divided by this side which is AC is equal to this side divided by this side. So BD divided by DC. So this is a formula which you should know because you do run into angle bisectors a lot. Rohit is mentioning, did I make a mistake in the previous question? Yeah, so 28 under root. Sorry. This will be root 28. My bad. 2 root 7. So this is a formula which you should know, and a lot of people do not know or get confused whether it's an angle bisector or whether it's for perpendicular or whatever. So it's for angle bisector, and then you can apply it in situations as shown in the question here. So here, if I had to calculate AC, I have been given other lengths, so I can substitute. AB is 3, AC I don't know, BD is 4, and DC is 5. So using this, I can calculate AC is equal to 5 into 3 by 4. Somebody is going pretty hard at the like and those buttons, right? I can see a lot of likes and I don't know what kind of emotions flowing through my video. Next question. So T is a right angle triangle whose perpendicular sides are AB and hypotenuse is C. And you have to find the minimum possible value of C by A. So we have a right angle triangle and we discussed the one main property of right angle triangle is the Pythagorean theorem. So you will start thinking like that. So we have a triangle, we have A, B and C. The hypotenuse is C. So what is the minimum possible value of C by A plus C by B? And C is equal to root A square plus B square, right? This is the only thing we know. So we'll start with that. How can we minimize this value? So A square plus B square by A plus A square plus B square by B. And you can simplify it like this. And now what can we do? What we can do is we know one thing, right? This seems like a sum. So we can try and apply AM greater than GM. So let's see, if we had to apply AM greater than equal to GM to the expression we got at the end, what we'll do is we'll multiply that. So this the expression that we have to minimize, this by 2 will have to be greater than equal to 1 plus B square by A square and into a square by b square plus 1. And you can multiply that and you'll get, let me make it a bit clear. So I multiply this, it comes down to a square by b square plus b square by a square plus 2. So at the end, what you get, if you assume a square by a square equal to t, what you are getting is an expression which has some positive stuff plus t plus 1 by t in between. And the minimum value of t plus 1 by t would be equal to 2. I'm sorry, I'll redo it from the beginning because that might make it clearer. I think it's getting a bit messy here. What we have been asked is there is a right angle triangle and whose sides are AB and hypotenuse is C, and we have to find the minimum possible value of C by A plus C by B. Okay. So to keep it neater, maybe I'll apply it at the beginning itself. You'll find the calculation also easier. So we need to minimize C by A plus C by B. And so we know that C by A plus C by B by 2, which is the arithmetic mean, would be greater than C by A into C by B under root. Okay. And this quantity is C square by AB, or C square can be written as A square plus B square. So A square plus B square by AB, or equal to A by B plus B by A. And A by B plus B by A are of the form T plus 1 by T, if I assume A by B to be T, and the minimum value of this expression is equal to 2 when both are equal. So the minimum value here is equal to 2, root 2, and therefore C by A plus C by B will have the minimum value of 2 root 2. I hope I was able to make it clear. It's not an easy question, but you can solve it. What we have been given is a right angle triangle whose sides are A, B, and C, and we have to minimize the value of C by A plus C by B. And we use AM greater than GM, and then substitute the values, and then we get to 2 root 2. So again, using very basic geometry principles, you can solve. Let's look at this question. We have been given three things. The length of the sides of an acute angle triangle. So there is an acute angle triangle whose lengths are 5, x and 12. How many integral values of x are possible? So we discussed just a few moments ago that there are those theorems which help you solve these kind of questions to some extent. So we know that sum of two sides has to be greater than the third side. So let's apply that. So two sides 5 plus x will be greater than 12. So what do we get from here? X is greater than 7. Okay. But is that sufficient enough? We also have more information here. We have been told that it's an acute angle triangle. Now here you need to know a property, and we'll discuss that here. If it were a right angle triangle, if this angle were right angled, then we would have said 5 square plus x square will be equal to 12 square, right? But it's not a right angle. It's not a right angle. This angle is actually smaller than a right angle triangle. This is less than 90. So probably these things are moving closer, right? They're not as far as they should have been for a right angle triangle. And for a right angle triangle, therefore, the relationship actually becomes 5 square plus x square less than 12 square. Am I correct? Yeah. Sorry. Let's think about it. So for a 90-degree angle, I need to make you visualize it properly. 5 square plus x square is equal to 12 square if it is a 90-degree angle. But if I want to keep this 12 constant and I want this angle to be less than 90, then I'll have to, how do I explain it? So this is for a 90-degree angle, the same length. And now we are keeping it at acute angle, but I want the length to be the same. So if I keep an acute angle, this length will become shorter. So I need to keep this is higher. So I'm not sure whether I was able to communicate, but what happens is that for an acute triangle, you'll have this kind of a relationship. 5 square plus x square will be greater than 12 square. And using this, you can actually solve this. So this becomes x square greater than 12 square minus 5 square, or 144 minus 25, or x greater than root 119. And we are given that x is less than 12. So which means that the only integer value that x will be able to take is equal to 11. Let me take, so the relationship that we need to understand is for right angle triangle, it is a square plus b square equal to c square. But for an acute angle triangle, it's a square plus b square greater than c square. And for an obtuse angle triangle, it's a square plus b square less than c square. So these three things we should know. I was just trying to help you visualize why that is the case. And I would still like to try once more. So if it's a right angle triangle, 3 square plus 4 square will be equal to 5 square. This is right angled. But if we reduce this angle, and now we have 3 and 4, then this length will be less than 5, right? This length has become shorter. So now 3 square plus 4 square, this won't be 5. This will be something smaller than 5. X will be greater than x square. And if we make it an obtuse angle triangle, we increase the angle from 90 degree. Then what happens is you have this 3, you have this 4, but this angle is greater than 90. So this length becomes 5 plus something, 5 plus x maybe. And so 3 square plus 4 square becomes less than 5 plus x square. So this is a good relation to know. We are able to solve this question using the same relation. Okay, I just forgot reading the comments. Last question, bouncer concept issue. I don't know which one you are saying. Viru is saying use cosine formula. It may be easier. On this one, might try. I haven't tried it that way. Ashutosh is asking why x is less than 12. It is given in the question, Ashutosh, that x is between 5 and 12. So that's it. Let's look at this question. We are given PQR is equal to PRQ plus 30 degree. So PQR and PRQ. So generally what I do in such questions is I'll assume one x and then I won't write a lot because that makes things faster. This is x. So PQR becomes x plus 30. Okay, let's start here, x plus 30. And we are given QPR plus STU is equal to 220. So QPR, this angle, plus STU. So we have given this sum of these two angles, which is equal to 220. SQ is equal to ST. So these two are, this is an isosceles triangle, and TU is equal to UR. So this angle and this angle are equal. So we have to find angle PRQ. So we have to find x. So we assumed it as x, we have to find x. What can we know directly from the image? This is x, so this will also be x. This is x plus 30, so this angle will also be x plus 30, which means, so that's fine. This becomes pi minus 2x, the other side, and which means this angle becomes 2x. And same way, this external angle is the opposite of two internal angles, so this becomes 2x plus 60. And since PSTU is a quadrilateral, the sums should be equal to 360 degrees. We know that these two are equal to 220 degree. So from there we don't get क्या कुछ गड़बड़ कर दिया क्या मैंने? So does that condition provide? Yeah. So 2x plus 60 plus 220 is equal to 360, right? So this equation we can write, and from here we get 4x is equal to 80 degree or x is equal to 20 degree. So we get this angle is equal to 20 degree. So you'll face many such questions. Nothing very complicated to do, but just be a bit comfortable in identifying the angles and then working through it. I think this one should be straightforward, right? There wasn't anything difficult. So two triangles, again, we'll go a bit into the basics because people do make mistakes in this kind of stuff. Two triangles are congruent means they're exactly the same, right? They're not like similar, they're exactly the same. Each side is equal to the other side and each angle is equal to the other angle. How can we identify whether angles are congruent? If all their three sides are same, that we can use this. So that is pretty obvious. If you know all three sides and they are the same length, then those triangles will be congruent. Their angles will also be the same. Side angle side. So if two sides match and the angle in between matches. So a lot of people make this mistake. So do not make that mistake. The angle should be in between. Then that triangle will be a congruent triangle. Angle side angle. Two angles are sorry. So two angles can be the same and the side in between is the same. Then also you can say that this triangle will be congruent, the other angle will be the same and all the sides would be the same. And that's true for either. So for angle, you don't need the side to be in between. The side can be anywhere. If two angles are same, then the third angle will also be the same. So ideally, if you know similarity, those triangles are similar. And if one side is same, then you can say that these triangles are equal or they are the same. So these are the things. There are also, you should notice what is missing in this case. You cannot say if all three angles are same, it's a congruent triangle or AA basically. You need one side also to be the same. Then only you can say that the triangle is congruent. So these are the conditions for congruency. Remember the ones which are there. Remember what is not there also. Do not mark SSA as a condition for congruency, which is the common mistake, that you see that two sides are same, that this side and this side is same, but this angle is equal. So that would not mean that the triangles are congruent. Not necessarily that the triangles are congruent. The triangles might not be congruent. So this is not allowed. Please remember this and you should be fine. Similarly, two triangles will be considered similar. Similar means that their angles are the same and their sides are in the same ratio. So this is kind of what similarity means, that this is A, B and C. Then the similar triangle would be magnified or a zoomed out version of that triangle. So these two triangles would be considered similar if their lengths are exactly in the same ratio. So A, B, C and A dash, B dash, C dash would be considered similar in that case. How can we identify triangles which are similar? If you all three angles are equal, then it's similar. If you have fixed two angles, then the third angle automatically gets fixed. So as long as two angles are equal, you can say that the triangles are similar. Okay. Side angle side. So here sides need not be equal. The ratio needs to be the same. So if I know that this angle is equal, and the ratio of AB to A dash B dash is same as AC to A dash C dash, and the angle in between is equal, then I can say that the triangle is similar. Or the third case is all three sides have to be similar, have to be in the same ratio. So I don't know anything about the angle, but I know that all three sides have the same ratio. Then we can say that the angle is similar. Again, I'm hoping most of you know it. Just a quick refresher and a pointer to what you should not assume, what conditions are there and what are not there. Look at a few questions. So there is a triangle, bigger triangle ABC, and then there is a smaller triangle A, B dash, C dash. B dash, C dash is parallel to BC. So uh, from parallel lines, we know that this angle will be equal to this angle. Okay. And this angle will be equal to this angle. So this is from parallel lines. And this angle is common. So if we compare A, B dash, C dash with A, B, C, we know that all three angles are equal. Angle A is common. Angle A, B dash, C dash is equal to angle A, B, C. And angle A, C dash, B dash is equal to angle ACB. So all three angles are common, and hence the sides will be in the same ratio. Which sides are in the same ratio? The sides opposite to equal angle. So if this angle and this angle are equal, then AB dash divided by AB will be same as B dash C dash divided by BC. So that is opposite to angle A for both the triangles. And again, this angle is equal to this. So in the smaller triangle, opposite to this angle is AC dash. So that will be equal to AC. So that way you know that these two triangles are similar. Similar triangles, another property is that the sides, if the sides are in the ratio k is to 1, sides are in ratio k is to 1, then area is in the ratio k square is to 1. Sides are in the ratio k is to 1, area is in the ratio k square is to 1. So here the sides are in the ratio AB dash is equal to 10 and AB is equal to 40. So sides is in the ratio 1 is to 4. So area would be in the ratio 1 by 16, right? Because the sides are in the ratio 1 is to 4. So the answer here will be 1 is to 16. I've done a lot of working, but those who are comfortable should be able to do it in like 5-10 seconds, because it's a fairly common question and most of you would have come across similar questions. You get such scenarios also. What we have done is there is this theta angle in the triangle, bigger triangle, and then there is a theta angle in the smaller. So if I have created a bisector, or if you created a division of this angle and one side is theta. What happens in such cases is, if you look at the bigger triangle, triangle ABC, let me draw it separately. So this is your bigger triangle ABC, and let's look at the smaller triangle BDC. So this is BDC. You notice that this angle is theta, which is equal to this angle theta, and then you have angle C here and angle C here common to both of them. So these two triangles become similar. Triangle BDC becomes similar to triangle ABC, which is not very obvious when you look at it first time. And you can use this property, it's not a property, but this observation to solve questions. Let's think. I think I have a question. So we have in a triangle ABC, D is a point on AC such that angle ABC equal to BDC. So it's slightly different, but fairly similar. So what we are given is ABC, or this angle, is equal to BDC, or this angle. These two angles are equal. Then we are given AD is 6 and DC is 2. We need to find BC, or this particular length. So when angles equal are given, most probably it would be a similar triangle related question. So you should start thinking along those lines. So let's see what we can do. Angle ABC and BDC, we have one angle equal, and we know that C is common to both, right? So this angle is anyway common. So we know triangle ABC is similar to triangle BDC. Which sides will be in proportion will depend on which angles are equal. So for ABC, opposite to angle B is AC. And for BDC, for equal angle, the opposite side is BC. And same way, we look at the common angle. For common angle triangle ABC, the length is AB. And for BDC, the length is BD. And so the third side will also be in the same ratio, or we know that BC from the first is equal to by CD. And now we can substitute values. We know AD, we know DC, and hence we know AC is equal to 8. So 8 by BC is equal to AB by BC equal to BC by CD. And we don't know BC, but we know CD. So we know BC by 2. And from here, you can calculate BC, right? BC is equal to under root 16 or 4. So again, this is use of similarity. This one again, fairly popular question. So it should not be, I won't spend a lot of time. You can do it yourself. What we have been given is there are 3 parallel lines. These are creating triangles. The ratio of this length is 1:2:3. So this ratio is given 1:2:3. So this is x, this becomes 2x, or this becomes 3x. And then we are asked to find the area of BCCB. This area we have to find, given that the area of the smaller triangle is 10. So what we know, what you should be able to prove is AB dash C dash is similar to AB dash C dash is similar to ABC. Okay, and what would be the ratio of their sides? So AB dash is equal to 1, B double dash is 1, B dash is 1 plus 2. This is a mistake we should not make. You should add 1 plus 2, and AB is equal to 6. So their sides are in the ratio 1:3:6. So their area, they will be in the ratio of square. So 1:9:36. So if the smallest triangle AB double dash C double dash has area of 10, which has been given, so if the smallest one has area of 10, then the bigger triangle, which is this one, so this triangle AB dash C dash will have area of 10 into 9 or 90, and the outside biggest triangle will have an area of 10 into 36 or 360. And we are asked to count this area, which is the part in the bigger triangle which is not in the smaller triangle. So that will be equal to 360 minus 90 or equal to 270. So again, not very complicated. Most people should be able to solve this, but it depends how much time do you take. Very commonly you will come across such situations. So let's look at this question. You'll see a right angle triangle, and then there will be a perpendicular from the right angled vertex on the hypotenuse. So, and then there might be other complicated stuff, but having analyzed this situation once might help you solve the question. One, these triangles are similar. So BDA and ABC will be similar. Again, why? Because one angle is 90. In this is a smaller triangle, and this has one angle as 90, and the bigger triangle says one angle is 90, and angle A is common to both, right? So both have angle A as common. So you can use that to calculate BD, and you can write, and same with this triangle will also be similar. So you can use that to calculate. Or the other way which you can do is just by calculating the area. So we know the area of the triangle is half into 16 into 12, right? Half into base into hypotenuse, but which is also equal to any base and any hypotenuse. If we assume this as the base, 1 by Pythagorean theorem, we know that this will be 16 square plus 12 square under root or equal to 20. So if 20 is the base, BD becomes the hypotenuse, right? And the area is still the same. So half into BD into 20. And so from using this, you can calculate length of BD, which is equal to 16 into 12 by 20. And that will be whatever, 48 by 5 it's coming. So 48 by 5 will be what? 9.6. So BD will be equal to 9.6. So you can use similarity, but you can also use equate area to get this. In fact, I have, from my experience, it's very difficult to think of area when you are thinking of these lengths unless you have been exposed to it before. And so I had actually almost a thumb rule. I had written it in my notebook that if nothing works in geometry, think about area, because I would always start thinking around similarity, congruency, blah blah blah. And so sometimes just equating area from different ways can help you get to length. So specifically, if the question is asking you to calculate a certain length and similarity, congruency, those kind of things are not working, then just think about area for once. Can you calculate the area from two different ways and equate it to get there? So, but anyway, from here, what we have done is we have just calculated this area. In case anybody has any doubts, no, it's a fairly fundamental question, but it gets asked in different forms in different places. Now, here it's a similar concept, but slightly more complicated. So we have again the same triangle, but then we have been given a square BDF. So this is a square. So all these angles will be 90. And now we have to find its area. So how will we go about it? First, this is a square. So let's assume its length is x. Okay, let's go with x. Now, what do we know? This is 90. So you look at triangle DEC, or this one, the smaller triangle inside, this triangle, and the bigger triangle. And you notice that one angle is 90 for both of them, and one angle is common. Angle C is common. So both these triangles are similar. So if the length of the bigger triangle is, if the lengths are in the ratio 16:12, this ratio will also be the same, right? So if we put EC for now just y, then what will be is the 16 by x will be equal to 12 by y, right? Or y is equal to 12 by 16x, or 3x by 4. So I can replace y by, I'll just replace it by 3x by 4. So this length is 3x by 4. And given that it's a square, this length is x. And I know the total length is 12. So I can just do x plus 3x by 4 is equal to 12. And using that, 7x by 4 equal to 12, you can do x equal to 12 into 4 by 7, or 48 by 7. So the side of a square is 48 by 7, and then if I need to find the area, I'll just multiply it. So 48 by 7 into 48 by 7 will be my area. And then you can look at the options, how the answers are represented and so on. But fairly straightforward. Just by using similarity, you are able to do it within seconds. You can do it on your fingertips. It's not as easy if you don't notice the similarity concept. So that's where it's helpful. Why don't you try this question? So I'll just take a couple of minute pause. In case you have had any questions on what has been covered, if you have any feedback on how we are doing this, feel free to comment, or otherwise just take a shot at this question, and then we'll continue with this. After this, we have 5-6 more questions. So I think we should be completed by 11:15 or something. Those are slightly tougher questions. Right, what we have done till now is relatively easier. So, but attempt this one first, and then we'll get started. What we have been given here is again a right angle triangle. From the midpoint of one side, we have drawn a perpendicular on the other side, and that is divided the side into lengths of 3 and 5. What is the length of BC, or the base of this triangle? So I'll wait for maybe 30 more seconds if you have an answer, and then we'll get started. So let's assume, so we have been given these lengths as equal. So let's say this is x, then this also becomes x. The total length becomes 2x. What do we notice? Triangle ADE would be similar to triangle ABC. How do we know that? There is this angle which is 90, which is 90 for ABC also, and angle A is common to both the triangles. So these triangles will be similar. If they are similar, then how will the lengths equate? So opposite to angle A in ADE, or the smaller triangle, is DE, and in the bigger triangle is BC, which is equal to, opposite to the 90 degree in the smaller triangle is x, and in the bigger triangle it is AC, which is 3 plus 5 or 8. And then in the smaller triangle opposite to the third angle, which is this one, is AE, which is equal to 3, and in the bigger triangle it's this, which has 2x. So using similarity, we can again calculate x. So x becomes 24 by 2, or root 12. So x is root 12. So we know this length is root 12. We know this length is root 12. The entire is 2 root 12. We have been asked to find this one. So we'll use Pythagorean theorem. The hypotenuse is 8. So 8 square is equal to 2 root 12 square plus BC square. Or you will get BC square equal to 64 minus 48, or 16, or BC is equal to 4. So you can use this to calculate. Is it clear? Not getting any response, so I am a bit worried now, because the question should have been solved in the time that was provided. So if nobody tried solving it, then I'm wondering where they got stuck. And we have a few more questions. So if people are tired, I can stop here also, because it would get a bit tiring, because there's just question after question after question, and you need to do that yourself also. You need to practice a lot of questions, then only you'll get better at geometry, specifically because the number of concepts that had to be done is limited, but it's just that the amount of questions you do, the more you will be exposed to different kind of situation. In the previous one, yes, it was AC is equal to CB. So here it was given AC is equal to CB. Maybe you didn't notice, but it was written also that AC is equal to CB, and we had given that as well. Yes, so little more time is actually make or break in the exam scenario, because a little more time might mean 2 extra questions, and 2 extra questions might mean the difference between 99.7 and 97.7, and that would be a disaster. So well, the first step is, Sai, is to at least know how to do the question. That's the first step. So at least if you're able to solve the question, then it's a good start. But then you need to bring down the time, at least for the easy questions, because in the exam it won't be an easy question. Exam, what you would have is a difficult question which will be built of blocks of easy questions. So if you have done a lot of easy questions, you would be able to solve it more quickly, like this kind of stuff which we did just now, where there is a 90 degree and you will have another 90. Now, this question won't come like this, because it's being taught in so many places that if you ask this, everybody would solve it within seconds. But it's possible that you have a scenario where this also gets employed, like something like this. There is a circle and there is something, and there's something like this. So if you have done this question properly, like this one you have done very well, then when it comes here, you at least recognize the part inside. So that's how you improve speed. That's how you get better at geometry, and better at any subject for that matter. That you do the easy stuff so well that then you get to the difficult ones, you are able to break it down into their easy components and solve. Let's look here. We'll touch on a way of solving which we haven't till yet, and might be helpful. You might face other questions of similar nature, and it's slightly difficult to observe when such questions come. So let's see, what does it say? So we have this triangle ABC, then we extended BD to the extent that AB is to BD is in the ratio 1:3. And same way AC was extended to CE, so that AC is to CE is in the ratio 2 is to 3. We are given the area of triangle ABC as 10 units. So this area is 10 units. Okay. Find the area of the triangle CDE. Find the area of the triangle CDE. So how do we find that area? What we know from right from the fundamentals is area of a triangle is half into base into height, right? Now you look at ABC and ADC. For both these triangles, if you assume AB as the base or AD as the base, the height would remain the same, right? The perpendicular from this line to this would be something and this would be some x. So the area would be in the ratio of the base because the height is the same for triangle ABC and triangle ACD also. Let's say triangle ACD. So we are looking at both these triangles, this triangle and the bigger triangle. For both the base, the height is the same, only the base differs. For one base is AB, for the second the base is AD. So the bases are in the ratio, AB by AD is in the ratio of 1 is to 4. So the area would be in the ratio of 1 is to 4 because we are just doing this half into B1 into H1, B2 into H2. And since the height is the same, so that doesn't matter. So the ratio of bases will be the ratio of area. So the area of triangle ACD will be equal to 4 into area of triangle ABC, or 4 into 10 equal to 40. So we know the area of triangle ACD as 40. And now we need to apply the same thing to this triangle. Look at ACD and CDE. Look at this CDE and the triangle ACD. Maybe I should change the pen color. Yeah. So look at this triangle. Again, the perpendicular from D would remain of the height, same height, and the base length is changing. One has the base length of AC, which is equal to 2. Other has the base length of CE, which is equal to 3. So their areas would be in the ratio of 2 is to 3. So if ACD's area is 40, area of DCE will be 40 into 3 by 2 or 60. So this is what we have been asked to find, DCE, and that area is 60. Okay, I'll repeat it again. Yes, Sai. So that's a very fundamental problem. I'll repeat this question, but I'll just answer Sai's comment. Ki once you know the solution, things seem easy. When you don't know the solution, things seem difficult. And it's fine. In the exam, it might not be as straightforward. You might take a lot more time than what it took me. But it should not take it should not take like 6 minutes or 7 minutes. Depending on the question, depending on the difficulty, it can take more than what I am taking, because I actually like solve these questions before putting it in the class. It's not like I'm seeing them for the first time. I try and find the more difficult ones or the best ones to teach. Then I have solved them once. So I know the right answer. So it's not like I'm solving under examination condition. So it would take a bit more time, which is completely fine, but it should not take a lot more time, specifically if things are like very obvious. Now this question, it's not very obvious how to apply. So here, if you take some time, it is fine. If things are very obvious or they are applications of questions which a lot of people have done, then you should not be spending a lot more time on that. And there you need to have a higher speed to what to say. Also, for some people, like even for personally me also, my speed improves in the exam scenario compared to at home. At home, when I'm doing, there are very many questions which I may not even be able to solve at home, which I was able to solve in the exam scenario. Because and you should actually try and get into that mindset. Suddenly you are so switched on, so much triggered, and you are so conscious of time passing that actually your energy levels are higher and you are doing better than what you would have done at home. So that's also a case. It takes practice to get there, and you need to enjoy giving the exam to get there, but you can try and aim for that as well. Repeating this question, first let's see what is the concept we are talking about. I am saying if this is a triangle and we divide it into two parts using this 1 and 3. What I'm saying is area of ABD will be equal to half into base, which is 1, if I assume this is 1, into height. Height will be the perpendicular from A to BC, right? And area of triangle ADC will be equal to half into 3 into height. And the height is the same because the perpendicular remains the same. So area of ABD and ADC get divided in the ratio of area of the bases, or 1:3. So this is the concept that we are trying to use here. We are given that the area of triangle ABC is 10 units. So this is 10 units. I notice that the base is divided into 1:3. So this part becomes 30 units, or total ADC triangle becomes 30 plus 10, 40 units. Now look at the same triangle from the other side. So I notice that this base is being divided in the ratio 3:2 by the vertex. So if this part is, sorry, it's 2:3 in the question. I miswrote right now. So if this part, which has 2 parts of the base, are 40 units, then 3 parts of the base will be 3/2 into 40, or 60 units. No. If math were so rule based, Sai, then it would have been such an easy thing, right? If this, then this, if that, then that, then we would just have remembered the rules and gone ahead and applied them. It takes practice. You need to try certain things. If you have done a lot of them, you know where you have a feel of where to apply what. And then in certain scenarios, you have to try different things also. You might go ahead with the area thing, it doesn't work. Then you see if there is a similarity related concept that doesn't work, and so on. So it's not a very straightforward, but you should be able to even try things out fairly quickly. If this works within 15 seconds, no, that won't work, what will work, and so on. So it won't be a very straightforward rule based thing. If side ratio diya ho to just use area, and if angle diya ho then use similarity. If it was so simple, we just won't test it. Like this one. Now this seems like a triangle related question. It's more of an algebra related question than anything else. If A, B and C are the sides of a triangle, and A square plus B square plus C square is equal to BC plus CA plus AB. So these are 3 sides of a triangle. And we have been given this, and then we have to say whether the triangle is equilateral, isosceles, right angled, or obtuse angled, or what and what and what. So one thing you can very easily see कि equilateral तो one way to वैसे ही देख लेना कि if A equal to B equal to C हो, then both these sides are satisfied, right? So it seems like it would be an equilateral triangle. Other way, if you really want to prove it, then just multiply it by 2 and then bring it to one side. This is 2A square plus 2B square plus 2C square minus 2AB minus 2BC minus 2CA equal to 0. And this can be written as A minus B square plus B minus C square plus C minus A square equal to 0. And so A equal to B equal to C is the only possible answer. So this is true for equilateral triangle. Now this is more of an algebra question. It is not a this doesn't have much to do with geometry, but you should know this. You might face such expressions in many other places, so how to handle and so on. So this is pretty straightforward. Ankit, are you trying to say something? I see just a blank comment. This is a question which refuses to die. I haven't done it today, but I have done it many times in the past. And each year at least a few people ask कि ये question कैसे होगा. So let's see if we can do it again. There is this complicated shape, and we have AB equal to BC equal to CD equal to DE equal to EF FG equal to GA. So what we have is AB equal to BC equal to CD equal to DE equal to EF equal to FG equal to GA. So all these lengths are equal. Okay. And then we have to give the value of this particular angle. So let's start. Let's assume this as X. Okay. This is an isosceles triangle. So what will this be? X. These two are X. So what will this external angle be? 2X. We know this. Can we use this anywhere else? Let's see. So again, So again, GFE is isosceles. So this is 2x. So this becomes 2x. Okay, so I have found something here. Let's keep looking what else we can do. Do we need to? So what I'll do at this situation is, if I am able to handle it only in x, then I'll only use x. I won't use a second variable. But if I get stuck, I might substitute a second one also. But generally it makes things complicated. So let's see. This is 2x, this is 2x, so which means this becomes pi minus 4x, right? Because those two are 2x and they are part of a bigger triangle, GFE. This is pi minus 4x, this is x, so this is pi minus 3x, which makes this as 3x, and which makes this bigger triangle as 3x. Okay, these two are 3x, so this becomes pi minus 6x, and this is 2x. So does that help? Yeah, so this is pi minus 4x, and so this becomes pi minus 4x. And if you continue to substitute, at some point you just get the answer. Let me just continue. Actually, I'll just solve it for now. This is 2x, this is 2x, this is pi minus 4x, and minus 4x, pi minus 4x, and now do I need to substitute? I don't want to take another way. So this one is again an isosceles triangle. So if this is x, this also becomes x, right? Because AB is equal to BC, x. And so this angle in between becomes 3x. This is 3x. And from there you get this one as pi minus 3x by 2. This one also has pi minus 3x by 2. And then I think this works. So 2 pi minus 8x. I hope it doesn't just cancel out, but minus 3x minus pi minus 3x by 2 is equal to pi. This won't work. Maybe I might have made a mistake somewhere. Let's start again. Actually, I will do it at the last. I don't want to bore people. It's not very confusing. It's actually pretty straightforward. And I have done it like 5-10 times before. It's just you assume one value as x and then you keep substituting and you get to the answer. I'll do this at the last question today. First, let's do the other stuff because I don't want to bore people with my calculation. But if you can try, you will also get the answer. Let's look at this one. Khyati, how to join these sessions? You're already in the session, so I do not know what your doubt is. D is equal to 40 degree. We need to find angle ACB. So we need to find this angle. What we have been given is that these two are isosceles and these two are isosceles triangle. So let's assume this as x. So this becomes x. This becomes pi minus 2x. And same way, if we assume this as y, this becomes y. And we get this angle as pi minus 2y. And we know that x plus y plus 40 is equal to 180 degree. Bigger triangle. This angle, and this angle becomes 180 degree. So x plus y is equal to 140 degree. So this we know. Now, what will this be? This will be pi minus 2x minus pi minus 2y. And this becomes equal to, I'll just clean it up a bit. The middle angle becomes 2x plus y minus pi. And x plus y we know as 140, so this becomes 280 minus 180 or 100 degrees. So this angle is 100 degree. This angle is 100 degree. And we need to find ACB. So ACB was what we needed to find. So we have found it. Is it that easy? Yeah, so it's 100 degree. So there isn't much else to do. I hope it was clear. What we did was we assumed x and y as the two angles. And then we knew that since the sum of the angle is 180 degrees, we have x plus y plus 40 equal to 180 degree. And from that we got x plus y is equal to 140. And since it's an isosceles triangle, this x will be equal to this x. So this angle became pi minus 2x. And since y, so this angle became pi minus 2y. And then what it meant was the angle in between would be 180 degree minus the two angles. So pi minus 2x minus pi minus 2y. And then you got 2x plus y minus 180 degree. And we already knew what x plus y was, so we substituted and we got the answer. These are questions which you will find it easier if you do them yourself. When I teach, it might seem much more difficult than when you do it yourself. So don't worry a lot about it. Just when you revise this session, and the video session has to be revised. If you think you will learn just by watching the session, you are wrong. You have to like write down all this stuff and do it yourself, at least twice probably. Then these things would be much more easier. You won't find this question tough or the previous one tough, and so on. This one is even more complicated. Actually, we'll do this one in the next class. Just try and attempt it yourself, but this is tricky. So I'll explain the question. We have a right angle triangle and we have sides of 12-inch sides. So this is an isosceles right angle triangle. Okay, it's cut into 3 parts. And each of them are of equal area. So basically this length will also be equal, as we discussed just beforehand. If the area is equal, these lengths will be equal. So these 3 equal lengths are there. Now we have to find the sum of perimeters of all the triangles in the picture. So it's one thing you have to be aware is it's not only these 3 triangles. There are these 3 triangles, but it's not talking only about these 3 triangles. You also have to consider this triangle. You also have to consider this triangle and all the triangles, the bigger outer triangle. All these triangles have to be considered. So you have to sum up the parameters of all these 3, and then why not? So for that you need to find the lengths. It's fairly it's not straightforward, but it's not very difficult. So you have 12, so you know the length of the other hypotenuse would be 12 root 2 using Pythagorean theorem. Since it's divided into 3 parts, you make it 4 root 2, 4 root 2 and 4 root 2. So we know these lengths, and then you will just have to assume the perpendicular and see how that works out, and using that you will need to you'll be able to calculate this length and so on. So that much I'll leave for you to solve. We'll discuss it in detail in next question next time. And again, I didn't discuss parallel lines, but there isn't much to discuss. Just remember this thing: if 2 lines are parallel and a transversal cuts through it, then these angles will be equal, the opposite angles will be equal. So that's all you need to know. I think most of you know it. If you don't, just look up in a book. I won't discuss it in much detail because it's fairly simple. That if there are 2 parallel lines, if this is 60 degree, then this angle will also be 60 degree, this angle will be 60 degree, this will be 60 degree, and these angles will be 120 degree. Actually, from the way it has been drawn, it seems opposite, but so this is the only thing which we needed to discuss. And next session we'll discuss these concepts: incenter, circumcenter, centroid. I haven't even like trigonometry and area related questions. So we did some area related questions. We'll do a few more, but we'll focus mostly on these 2 parts. I think trigonometry also a bit of height and distance is required, so we'll do that, and we'll focus on these concepts. But today it was a warm-up. It was our first session on geometry, so we kept it to slightly more common stuff as well. And that would be it. Now, if you want to leave, you can leave. I'll take one more shot at this, and hopefully we should get there. AB equal to BC. So this is x, this becomes x. BC is equal to CD. What can we do? This is x, so this becomes 2x because this is an external angle. This is pi minus 2x. And so this angle becomes 2x. CD equal to DE. Can we do anything from that right now? Okay, so this is 2x, this is 2x. So this becomes pi minus 4x. And since this is x, this becomes pi minus 3x. So this angle becomes 3x, which means this angle also becomes 3x. Okay. And since the triangle, the bigger triangle will be sum up to pi. So this angle is 3x, this is x, this is 2x. So these are 6x. So this angle becomes pi minus 6x. Okay. Now what else do we have? CD is equal to D. That much we have already captured. D is equal to EF. So we use this also. And using this, we can say this angle is pi minus 4x. So this becomes pi minus 4x. Okay. And which means this becomes pi minus 2 pi minus 8x, or 8x minus pi. And so now you will start getting again a bit confused. So it's easier when you do it rather than when me doing it. This becomes pi minus 5x, and DEF equal to FG. EF equal to FG. That is pi minus 5x. So this is also pi minus 5x. And FG is equal to GA. I also remember the answer as pi by 7 now that you have posted it, because it comes up to, I think, 7x is equal to pi or something like that. So pi minus 5x, and these two are equal. So this is x, and so this becomes pi minus 3. So this becomes 3x. And so by summing these three, you get pi minus 5x plus pi minus 5x plus 3x is equal to pi, or pi is equal to 7x, and hence x is equal to pi by 7. So basically you have to write all those in terms of x, and then you get, at some point you get three angles of a triangle which are all expressed in terms of x, and then you can sum them up to get equal to pi and get the answer. So try attempt it yourself. I think you should be able to do it. But thanks for attending today's session. Let me know if you have any suggestions on how we need to run these. I keep asking them, don't get anything back, but if you have anything, I'll be happy to oblige. And thanks a lot. I'll stop. Have a nice Monday tomorrow.